this molecule, and it says, I'd rather have this attached to me than in this structure. And that's energy minimization. That's kind of the secret of chemistry, is energy always goes down, or enthalpy. Sometimes there's entropic considerations too, but this is the main thing. So iron is called Fe3+ because its oxidation state is 3. 3 of the electrons, the 4s electrons and 1 of the d electrons is involved in bonding. So it's kind of shared. So oxygen's taking 2 from this iron, and 1 of these guys goes over here. So this guy's giving up 3 electrons to participate in this bond, and similar with this one. So you get Fe2O3. That's rust. But then when you go to this, why does citric acid dissolve rust? Well, I can't give you the thermodynamic energetics of it, but the carboxyl groups want to attach to iron. So you can see there's multiple oxygen atoms attacking each iron atom. So they're basically pulling the iron out of the iron oxide. So this is really useful because you don't have to do anything. You just dump some of this stuff in a bucket, put your part in there, boom, and you get stuff. I'm not very good at it yet. I did a little bit of it. I'll show you some pictures. But so what happens is it's called complexing. It may be a little different than a covalent or an ionic bond. It's just a little different kind of chemistry, but the iron is basically loosely attached to all these carboxyl groups. I can't even tell you where they are in that diagram. It's kind of complicated. So what comes off is called iron citrate, or this is the chemical name, but we won't go into that. So then, this is what you do. So there's some citric acid, and I brought some bags. You guys can take a couple tablespoons and try it on your own. I have this little Tupperware. My wife wouldn't want me to reuse it, but it's now in my wood shop. So put a couple tablespoons of this in with water. That's my water jug. I just tried it on some bolts. I got old bolts. There's the thing that Ken gave me, citric acid, 2 tablespoons per cup, I think it says, dissolves rust. So you put it in there and it starts bubbling, and you're basically liberating hydrogen. So remember back here, this thing has hydrogen on it. The citric acid has hydrogen, but it transforms in this reaction, so you're going to get hydrogen bubbles off. It won't blow you up, don't worry about it. Just maybe you don't want to cap it, or you don't want to have it in your closet.
You don't want to be smoking near it.
It's don't smoke. I don't think it's even much. So that's that. It's probably so loosely, it's so dilute it won't. I probably couldn't even light a flame. But anyway, this is what I did. So I got this plane from Ken, and it didn't look like this when I got it. It was rust. And then I tossed it in this citric acid for a while. This one I bought it at Habitat, and I'm like, well, it's not that bad, but it had paint all over it. So I sanded it to 240, it says on there. This one's just done, it didn't do any sanding. And then I went to sanding it, I kind of went backwards, so they're both at 120 now. And I'm sorry, my photo capability is bad. But this is my system. So I have some sandpaper strips. This is like adhesive sandpaper, and I put it onto some tile. I have a tile saw. We did a lot of tiling at home. Cut these things out of leftover tile. I made these little things. These are the planes, and then you need a brush. You want to sand it and then get the stuff off of the sandpaper, otherwise the sandpaper just clogs up. So that's what I did, and then I can proceed farther. Like I went to 180 actually. I'm not sure what this is at right now, but if anybody that knows sharpening right here, you go to like up to maybe 400, and then you start going for stones, like 1,000, 4,000, 8,000 if you're really into it. Probably 4,000 good enough. This is pretty good now. I mean, this is basically flat. You know, you could use this plane right now. This is not the business end. It's the plane part, which the blade that fits in there, I also have that, but I don't have a picture of it. Okay, so what are other carboxylic acids you might have? Acetic acid. See, it's just methane. Methane is the simplest hydrocarbon. It's CH4. But this is CH3 carboxyl. This is another carboxyl group. These things are really important in organic chemistry. This is butyric acid, pretty much same thing, but has one more carboxyl group on the end. So when you hear carboxylic acid, don't think it's something real weird. But the weird thing about citric acid also has this hydroxyl group here. I didn't really mention that. I don't know too much about its effect in the chemistry. I looked through a bunch of stuff I couldn't figure it out. So anyway, that's that. And then what else can you do if you don't want to do this process? You can use mechanical process. Probably a lot of people have done this. Just start sanding, wire, grinding mill, still wool. It's pretty simple. You can just do it on a workbench. You don't need any chemistry. And what if you have a metal railing? You can't put it in a tub. You got to do it with your wire stuff. And then you don't have to think. Well, you don't have to think about chemistry. It's a mechanical process, but it's hard because you need to work on it for a long time. It's like sanding. It's hard. This other thing, you just put it in there and come back a day later. You're like done. This is an interesting one. Like you guys probably seen navel jelly. Mm-hmm. This is probably your compromise because this stuff is like jam. It's kind of thick, so you can paint this on a. This is the active ingredient, but it's in some sort of gelatinous material. You can paint it on stairways and things and work that way. Another option is the blast furnace, but you won't be using that. So that's how they make iron. They put iron oxide with carbon or coke and make iron and carbon dioxide. And then the last is electrolytic decomposition. So this is possible. I've tried it. It didn't work that great. I thought the citric acid was better, but maybe I didn't have my conditions right. You basically have a power supply, something like 12 volts, like a battery charger, and you put your thing in the solution, and you also have to have a conductive thing. This is really exaggerated. Like, few people have a full metal tub that they can use, but within a plastic tub, you just put a rod in or something with it hooked up to the positive and the negative. And I always forget this in terms of electrochemistry. Cathode and anode is a complicated thing, but whatever. So anode is the positive. It depends on which direction it's going to, so it's very complicated. But use sodium carbonate. This is not baking soda. I'm not sure what sodium carbonate is. So about that, water, like battery charger. Oh, sorry. Oh, great. What have I done? Okay, let me go back here. I'm sorry about that. Well, we'll leave it at this. So, and you need iron. You can just put a metal rod in. You don't have to have a surround thing. Here's some videos. The chemistry is like the iron gets converted to iron hydroxide, and then the iron hydroxide gets converted to iron. And there's some things that fall out, but also at the other electrode, you'll have conversion of hydrogen to hydroxide and hydroxide back to water. So it basically is just a big cycle involving water, hydroxide, hydrogen, and iron oxide. So this is just an idea. If you want to try it, I brought some citric acid in. All you need is a little baking soda, a little Tupperware, and your part. And this is kind of a pain because think about it, like what if you've got a whole bunch of parts? Like you've got a blade, you've got a body, you've got a screw. You have to wire everyone up. But you don't have to do that with citric acid. You just put it in there, let it do its thing. So,
How long?
What's that?
How long does it take?
I'd say like
Depends on how
4
much it
hours.
costs.
Yeah, and also the
Depends on
other
how much it
thing is, there's a concept in chemistry called stoichiometry. You will eventually use up all of your chemicals and it won't go any farther. So all the precipitate will fall out and it won't be proceeding anymore. So then at that point you have to just regenerate it. You like drain it, wash it. And the other thing that I didn't mention is you're supposed to neutralize it. You're supposed to put it in a basic solution like baking soda and water when you're done with the acidic process. But I didn't even do that. And Ken said, spray it with some WD-40 and WD-40 gets the water off the system so it doesn't continue corroding. So it's just a good thing to know about. I just wanted to explain some of the chemistry in case you guys are interested. I know it's kind of techie, but whatever.
So citric acid will attack the rust, not so much the iron.
Right.
Use acetic acid, which is basically white vinegar. White vinegar is cheap and inexpensive too. You can buy that, $3 a gallon. You can immerse your tools in that. But with acetic acid, it'll also eat through your iron. Mm-hmm. If you leave it in long enough, you've just eaten away all your iron and you pitted your thing. But it destroys it kills or dissolves the rust faster than the iron. So that's the good news.
That's good information because I didn't know there's like all sorts of alternatives listed. Like you try acetic acid, and there's, I mean, do it yourself or DIY videos are everywhere on the web. So you just look up some guy, like, I put this in here for 2 days, came back, look, you know, so I don't know, but this worked pretty well. And
Nice.
like, if it's really heavy, like I had some heavy scaling, it won't work as well. So what Ken gave me was just sort of surface rush-ish thing, and I didn't really have to do much. It was great.